Okay, so this is completely unrelated, even though the slide background is the same. This is going to be just a really quick once-through on how to use VLANs to secure an end site. This is not about your big network that goes across the country. This is about one location, one building, a bunch of machines in an office. How do you make them a little bit more secure? A lot of people have opinions about how firewalls work. A lot of end users have opinions about how firewalls work. Mostly, they are constrained by what they have been marketed. And the marketing people have been creating a lot of expectations about how firewalls work and what terminology should be used to describe them and so forth. And I think that's causing us some problems. There's this big artificial distinction between packet filtering firewalls and stateful inspection firewalls. 5 years ago, that was reasonable. Now, it's not really actually useful. Anybody who's doing any sort of major firewalling has some stateful inspection features and some packet filtering features and some of this and some of that and everything that's proven necessary in the last few years to fight the actual real-world attacks. Also, there's this inside-outside DMZ terminology that has come to really dominate the way people construct mental models of this stuff. If they don't actually understand how the attacks work, they're instead trying to formulate a kind of naive security policy for a site. So I would like to try to get folks to think in kind of more modern terms about that so that they don't get trapped in the problems that solution set creates. So what I see a lot of in enterprises, small enterprises, is they go out and they get a really expensive stateful inspection box, spend 40 or 50,000 bucks on something that has 3 Ethernet interfaces, runs Windows, and has some application on it, right, that does stateful inspection. It's always incredibly slow. Throughput is never very good on those. They typically crash pretty frequently, and you get a call in the call early in the morning saying the internet is down. And you say, that's funny, I can ping your site router, I can't ping any further than that. Maybe you should reboot the firewall again. And then everything magically gets better, and they say, couldn't have been the firewall, we paid $50,000 for that. So, the problem with the inside-outside DMZ 3 zones and the inside and the DMZ being basically a one-way filter and the outside DMZ being, a few ports allowed through is twofold. We're seeing more and more attacks that use the actual service port as their point of entry, right? Windows box sitting there, port 80 effectively tunnels the attack in for the attacker. That one, there's no real way around in a packet filter or even something that doesn't have very up-to-date understanding of the content of the packet. We're not going to win that one, right? We can't make everyone update all of their firewall devices every few minutes. We've got to have a more generic solution to contain problems when they occur. And none of this protects at all against end users within your organization that you don't completely trust. So, stepping stone attack, here's the sort of traditional inside-outside attacker on the outside. You've got a server with some known vulnerability. You're allowing a port through to that server, and then you've got other stuff on the inside, right? The attack channel comes through the allowed port, turns into a control channel. The compromised server is used as a stepping stone to attack other stuff that should be protected because it's behind the firewall, right? Except the firewall is just one monolithic thing. That turns into a control channel, blah, blah, blah. Okay, so untrusted user attack, you've got your DMZ that's sort of between the inside and the outside, or it's a third zone or whatever. You've got a whole bunch of allowed stuff between the inside and the DMZ, so that's not a very strong firewall, and then you've got allowed ports between the DMZ and the outside. Untrusted user uses one of the allowed ports, attacks one of the inside things, so forth. So, the kind of principles that I use when I'm trying to advise people about how to do this are, first of all, don't add points of failure, right? If your solution involves an additional box, it's probably not a good one, right? Because additional boxes are bad. You've already got boxes. Boxes have lots of capabilities, zillions of capabilities that you're not using. Maybe you should take a look at what the boxes you already have do, especially since the boxes you already have are fast and you already understand them. So also, most of these standalone stateful inspection boxes, at least I don't know of any that really understand VLAN trunking. VLAN trunking allows you to do some really neat tricks, which is what I will get into here. Here's the sort of simple packet filter idea, right? You've got the outside, you've got a router, you've got the inside, you've got your switch fabric. You put one big packet filter in the middle of the router between the outside and the inside. Right. Traffic comes in, gets filtered. If it's clean, goes through. Okay, so if instead use a VLAN-based inside, then you can have a whole bunch of little separate packet filters, each one purpose-specific to the stuff on that VLAN. The stuff on that VLAN is probably just one machine. The stuff on a VLAN, then, is stuff that shares a common security policy. So use the router. Sorry, okay, well, all right, again, that's kind of obvious. Now, if you have one big packet filter, you're executing the rule set, right? The rule set may be really big, right? Let's say it's not really big, it's just 40-line rule set protecting a bunch of stuff behind it. On average, maybe out of 40-line rule set, you're going to execute 20 rules before you find a match and you either discard or pass the packet and go on to the next packet and start executing it again. If you instead split that into a whole bunch of little rule sets, the router can route really fast. In this instance, routing means picking which output VLAN it's going to go onto, right? Once the router picks which output VLAN, then you start executing a packet filter or a rule set or whatever. That means the rule sets can be very short. So let's say they're now 4 lines and you're executing 2 on average instead of 20. That means you can go on to the next packet 10 times faster because you've divided the work in 10. So on a switch, what this looks like, this is just using a little catalyst as an example. And here I've got in yellow the kind of, yeah, you can see the yellow, the numbering that we use internally to sort of keep everything tied together, because this does involve a bunch of parts on 2 devices that have to be kept synchronized. So if we have, say, switch 3, interface 41, we'll just call that, number 341 for this purpose. We throw in a description. We say what VLAN that output port on the switch is attached to, configure the VLAN and name it. Then on the router, we have a Ethernet interface facing the switch fabric or GIGI or whatever. It doesn't have any address on itself. Instead, we have a whole lot of VLAN-specific sub-interfaces. What I'm not showing on here is that we have the default VLAN, VLAN1, which we don't put anything on. Or we just put infrastructure devices, not any server things that need to be accessed from the outside. So then we've got things with common security policy. Here, as an example, a DNS server. Tie one of the virtual sub-interfaces to that VLAN. We have input and output filters, so we can control both directions. Tie it to the specific VLAN, give it an address, and then we've got the 2 filters. So here we're just sort of allowing any sort of reasonable DNS traffic into the router from the server, and out towards the router we're just allowing queries. And that, you'd see more of the screen we're taller. Okay, give a more interesting example. What about the tricky situation of we have a VPN endpoint box? Something like an Altiga or a Sonic Wall or something like that, which thinks that it has an inside and an outside. It thinks it's kind of like a little baby firewall that does encryption, IPsec. Is this a special case? No, not using this model. This is just a server with two interfaces. One of the interfaces allows IPsec traffic in from the outside and IPsec traffic out to the outside, and that's it. So you can't attack it any other way. One of the interfaces allows most kinds of traffic to your other servers internally, but not all, and most return traffic, but not all, and doesn't really allow anything to the outside world at all. So walk through this one quickly. Traffic enters from the outside. First rule set is going to filter out anything other than IPsec, so you can't do like an HTTP-based attack on the management interface of the VPN endpoint. Traffic comes in, decrypted traffic comes out of the VPN endpoint. Then we've got another rule set there that's saying, well, this is somebody who came in on VPN. So we know they've authenticated using a password or using a card key or something like that, but we can't actually see them. We don't know that it's not somebody's kid, right, or somebody's broken into an employee's house or whatever. Therefore, we're not going to trust them in exactly the same way we trust somebody who's walked in and sitting in front of a machine in their office. But we're still going to give them access to most of the stuff that they would have had access to anyway. So we can do a different security policy than people coming in straight from the outside or than people coming in from desktops. And then out again towards the server, we control the ports exactly like we would for services in and out to the rest of the world. So that's that one. Questions on that? Keith.
Hi. Keith Mitchell, Exchange Point. Pardon me. I actually have different reasons for asking this, or rather it's more of a comment than a question, which is that I think it's quite a neat scheme. I think the 802.1q sub-interfaces and routers are a good idea, and I'd quite like to see all the router vendors support them. I'm not sure who supports them apart from Cisco. One possible drawback is sub-interfaces at the moment don't tend to have a lot in the way of packet counters and accounting on them. And again, that would be a nice thing to see supported from the router vendors.
Yeah, definite agreement on that one. One of the big problems is that a lot of vendors don't have SNMP counters, as Keith is saying, for VLAN interfaces. One of the reasons people do this is because if they pop an ACL onto the interface, inbound and outbound, and they can use NetFlow information to get their average packet size, they can get a packet count in and out on each of the VLANs or each of the sub-interfaces, and then multiply that by the average bytes per packet, bits per packet, whatever. John.
I'm glad that you did this presentation. It's something that I think makes a lot of sense, and I would like to see a lot of other providers doing this. Two questions. One is, what do you see as the added complexity to troubleshooting and management from a network operations, knock-monkey kind of perspective? And then part two is, along those lines, what do you have as recommendations for how do you keep track of 1,500 VLANs and the /30s that you assign to it, or the 28s or whatever, and making sure that switch configs, router configs, DNS, et cetera, is all appropriately glued?
Let me take those in reverse order. Question two was how to keep track of all of this stuff when it gets large. We sort of aggressively force all this stuff into ASCII and keep everything in ASCII flat files, basically, and have a lot of just little in-house Perl tools that go and find stuff and use grep a lot, and that sounds pretty simple-minded. I think if someone were doing it on a much larger scale than we were, they'd switch to a database backend that would generate config snippets automatically. We're not doing that, but we're also not doing this in such a large volume that that's a problem for us. On average, I think we're touching 50 to 75 ACLs a day among 3 people doing this in our security staff. If we were doing 2 or 3 or 4 times that volume, we'd definitely be looking into at a database for managing it. I mean like an SQL kind of database as opposed to the tools that we've written in-house. Question number 1 was relative complexity. There's obviously a complexity overhead here in keeping the pieces tied together, right? Because it requires a VLAN, an interface on the switch, an interface on the router, an inbound access list and an outbound access list, and any other security features that are being applied to the sub-interface. That's a lot to keep in your head if you don't do this frequently. If you do this frequently, it's second nature. The problem here is this gets difficult to hand off to naive site administrators. We do this because we manage security for a lot of our customer sites, and this becomes very easy for us. The big win here for us is the tiny little ACLs, right? The ACLs get very short and very purpose-specific, and you throw in a lot of comments, and you can become very stateless in the way you deal with them, right? A NOC person can pull up an ACL, see immediately what it's trying to do, right? Look in the comments and see exactly what the idea behind that ACL is and work with it and slam it back in, all without ever having to think about what the interaction between that and some other servers or whatever might be, right? Because it breaks out the functions of a big ACL into a lot of separate ones that don't have interconnecting.
You're not dealing with flows inbound and outbound and what way the SIM setup was, and et cetera, et cetera.
Yeah, exactly.
Right.
So it's very definitely a trade-off. It's a really good trade-off for anybody who has to deal with this a lot. It's a really bad trade-off for anybody that deals with it once a month.
Just a quick follow-up. The other question I have is redundancy. We spent a lot of time yesterday on infrastructure redundancy and so forth. One of the arguments that I usually get back from providers when I'm trying to, run 100 meg to a CAT 2900 and break up your VLANs into 10 meg ports or gigabits or what have, is what happens when that single interface fails. What are your recommendations for that? And then I'm done and Ted can go next.
Honestly, the way we're putting this in, it's usually for end sites one of the reasons I like the little switches is that it's easier to do cold sparing, right? So we tend to recommend little stackable switches, like to give a vendor-specific example, CAT 3548s, right? A big stack of 3548s tied together with gig rather than a, 6500 or something where if the thing fails, you're just out of luck until a replacement shows up. So, Ted?
Kind of a question on scaling. When I first saw you doing this, I thought that you were actually dividing things into categories. So you had like a category of VPN users, and they would have the short little ACL of VPN users. But in your example, it looked like you were down at the /30 level. And again, with John's comments, my question is, if you're doing it really at that level of granularity, are you in essence going to have to say we're not going to do DHCP anymore because we have to have a specific ACL assigned to a specific IP address, assigned to a specific desktop?
No, we divide it at the unique security policy level of granularity. That is, if we have 50,000 users who have identical security policy, we have a set of ACLs and an interface facing those 50,000 users. If we have
50,000 would be over your VLAN limit, so it's good to get
right,
that.
exactly. So frequently we will set one up if a site has 2 DNS servers. We'll put both DNS servers on the same VLAN, for instance, or that kind of thing. We are running out of time. We need to get Dave Meyer up here.
I will follow up.
Okay, thank you.
Thank you.